as amines. It is also called as organic compounds containing nitrogen. Till now we have learned three chapters. First one is alcohol, phenol and ether, where oxygen was the atom. Aldehydes, ketones and carboxylic acid, where C double bond O group was there. And now we are learning amines, where nitrogen plays an important role. Okay. So on 10 minutes we can see the definitions and classifications here. Amines are regarded as derivatives of ammonia in which two or all three hydrogen atoms are replaced by alkyl or aryl groups. Okay. So what is the meaning of this one? See, when you take the inorganic compound ammonia, it will be having the pyramidal structure like this, where nitrogen is surrounded by three hydrogens and one lone pair will be there. The derivatives of ammonia means what you should do? You should remove this H and replace by R. Remove this H, replace by R. Remove this H, replace by R. Okay. But when you place one R, it becomes primary. If you place two R, it becomes secondary. When you place all the hydrogen, then it becomes a tertiary. This is the meaning of this first line. Okay. So it is a definition of amines, and you can see here he has given classification based on that only. He has taken the ammonia compound, replaced one hydrogen atom. I got the compound RNH2, which is called as a primary amine. Replace two hydrogen atom, we get secondary amine. Replace all hydrogen atom, we get a tertiary amine based on that. If I take one example by replacing R, I can tell you like this: CH3 dash N lone pair H and H. In place of R, if I write CS3, it is called as methylamine. And now again if I write CS3, dimethylamine. Again if I write CS3, it becomes trimethylamine. And you can remove this lone pair also. That time you cannot substitute R, it becomes a plus charge. Okay. So like this we can replace R group by the different compounds. Now we move towards preparation of amines. There are many methods to prepare amine. So first one is by reduction of nitro compounds. Nitro compound means what? The alkyl group which is attached to the NO2 group. That is, N will be the central atom. Nitro compounds can be catalytically reduced by passing hydrogen gas in presence of Rane nickel catalyst. So this catalyst you have to remember, Rane is the name of a scientist. He is using the nickel catalyst as a reduction agent or reducing agent by passing what? Hydrogen gas. Whenever you see the hydrogen gas, it is nothing but called as a reduction. Okay. In presence of Rane nickel, finely divided platinum or palladium as a catalyst. While we are taking platinum or palladium, it is a d block element. It is having a large surface area and unpaired electron. Okay. Take the nitro group compounds, add Rane nickel, add platinum or PD, you get the amines. Okay. So now, next point. That is second one. You can see the reaction RNO2 plus 3H2 means why added 3H2? Because water will be liberated. In presence of tin and HCl, iron and HCl, or you can use platinum and HCl. Okay, we get the compound which is called as a amine. Next one, by Hoffman's method. And if you see 5 years or 6 years question paper, 2 to 3 times he asked about the Hoffman's method. It is also called as a Hoffman's degradation method, where we are taking cyanide compounds and converting it to amines. So what is the statement here? Ammonolysis of alkyl halides. Reaction of alkyl halides with ethanolic solution of ammonia. If you take only ammonia, you get the amines. But if you take alcoholic ammonia, that time what happens? The number of carbon atoms may increase or decrease. And we know that it is a degradation, means carbon atoms goes on decreasing. Okay. Solution of ammonia in a sealed test tube at this temperature forms a mixture of primary, secondary and tertiary amine. Okay. The process of cleavage of CX bond by ammonia is called as a ammonolysis. You can see this reaction here. R, okay, N, lone pair, H and H. Add alkyl halide or haloalkane. What happens, sir? This R will come and sit here. H will go with the X. That time, however, we will write R same, N same, lone pair same, this hydrogen same. Only change it becomes RR. Which went outside? Rx was there. X and H went outside. So I will write minus Hx. Again to this, add Rx. That time what happens? Again this R will be coming here. H will be going with X. So it becomes minus Hx. And here we get R dash N lone pair R. Okay. And now the last option, no hydrogen, but lone pair of electrons are there. Due to that, again add Rx. R will come here and no, nothing will go towards the X because H is not there. That time we should write R, N, R fixed. Here lone pair went outside, it becomes plus and this will remain as a X minus. Okay. Primary, secondary, tertiary, quaternary. Minus Hx, here nothing because no hydrogen. Okay, this is the Hoffman's degradation method. Okay, next point. Here you can see order of reactivity of halides. When you take the halides, that is Rx, in X you can take chlorine, bromine and iodine. Okay, but when how you take means Ri greater than Rbr greater than Rcl means who is more reactive? Ri will be more reactive due to the size of the atom. So as given the point, larger the size of halogen atom, easier is the cleavage of Rx bond. Easily you can break that bond. Limitations of this method is also there. The method gives a mixture of amines which are difficult to separate in a laboratory. As I already told, when you take the nitro compounds, react with this one, that time we get the mixture of all the compounds. Easily we cannot separate them and distinguish. Methods to get only one product by Hoffman's method. This was the drawback for this process. Okay. Next point. Okay. Method is not suitable for the preparation of aryl amine. This one you have to understand. Aryl means what? It should contain the benzene ring. Therefore, it is not suitable for that. Because aryl amines are relatively less reactive than alkyl amines. Why they are less reactive? Because of the presence of the benzene or aromatic ring, they will not easily form the compounds. Okay, towards nucleophilic substitution. By reduction of nitriles, next method we go for reduction of nitriles. How to do that? Nitriles can be reduced to amines using hydrogen, nickel, lithium aluminium hydride, sodium mercury amalgam in presence of ethanol. Okay, means nitriles means what is the formula? NC. We are getting the compound. By reduction of amines, you can take the amide compounds and directly you can convert. If you are not able to see this reaction, I will write R C double bond O NH2 in the presence of LiAlH4, we get the compound RCH2NH2. That is called as a primary amine. Okay. By this method also we can prepare the amines. Whenever we solve the question, that time again different methods I will be telling. Okay. Next one, by Gabriel thalamide synthesis. This is also the important reaction. Thalamide means it contains a 2-benzene ring. What is that? It is used for the preparation of primary amines. When thalamide is treated with ethanolic KOH, it forms a potassium salt of thalamide, which on heating with alkyl halide followed by the hydrolysis. So one by one line to see. First one, when thalamide is treated with ethanolic KOH. First you take a thalamide compound, add the alcoholic KOH, it forms a salt, that is a K form, which on heating, again you heat that with alkyl halide and do the alkyl hydrolysis, you get the primary amine. Okay, so this is the reaction for that. You can see here, this is called as a thalamide, which is having a 2C double bond group, add alcohol in KOH, you get potassium phthalamide salt, add RX compound, you get N-alkyl phthalamide, then you will get this product. Okay. Again, I will write the final product structure here. It is like this: C double bond O plus Na plus, O minus Na plus, O minus Na plus. But whatever the product is there, it is called as a RNH2. That is called as a primary amine. Okay. So this was the preparation related to amines. And you know about the physical and chemical properties. That is called as amines are less soluble in the water. Okay. Now we move towards the question. So this is the first question I have taken. The amine formed from an amide by means of bromine and alkali. See, first understand. The amine formed from an amide by means of bromine and alkali has how many number of carbon atoms? So first understand the question what he is telling. You have to take the compound that is called as a amine formed by the amine by using Br2 and KOH, that is bromine in alcoholic KOH. How many number of carbon atoms will be found? Same number, one less carbon, one more carbon, two more carbon than the amine. Okay, first see, if I take the amine, what will be the formula? CS3C double bond to NH2. Okay, and when you react with this one, it forms the compound CS3NH2, that is NH2. When you count the carbon, what happens here? It is 2. Here it is only 1. Means it becomes less. Therefore, one less carbon atom that of the amine. Hence the answer is B. That is the question. Okay. Next compound, you can see the reaction also. The compound X is which of the following? So he has given one reaction. Here we have to understand which one will be the X compound. He has taken CH3, C triple bond N, that is methyl cyanide, in presence of Na, C2H5OH. You get the compound called as X. Whenever you take the alcohol and sodium, that time you should get compulsory the compound called as a amine. Okay, and that should be the same number of carbon. So this is the amine, option wrong. This is the amine, it may be C2H6 hydrocarbon, wrong. This is amine, but it is a secondary amine. Therefore, the answer is wrong. Answer is ethyl amine. Explanation: reduction of nitriles lead to the formation of primary amine. Reduction of isocyanide lead to the formation of the secondary amine. I can write this reaction here. CH3, C triple bond N plus 4 moles of hydrogen in the presence of Na and C2H5, we get the compound which is called as CH3, CH2, NH2. That is the preparation of amines also. So the answer for this question is B. Next one. Ethyl amine can be prepared by the action of bromine and caustic potash on which compound? So what is the question here? Take the ethyl amine and add again bromine and alcoholic KOH. On which compound you have to add? It is acetamide, whether it is a propanamide, it is formamide, methyl cyanide. So one thing you have to understand, it should be compulsory amide compound. Methyl cyanide, wrong option, remove that. Now I left with only 3 amides. But here what you have to understand, here the compound is ethyl amine. Ethyl amine means it contains 2 carbons. When the product contains 2 carbons, you have to go for the reactant which contains more than 1 carbon atom. If you go for acetamide, CH3C double bond O NH2, how many carbons? 2. If you go for propanamide, CH3CH2 C double bond O NH2, how many carbons? 3 carbons. Formamide means HC double bond O NH2, only 1 carbon. So what I told here, it should be more than 1. Therefore the answer will be propanamide. How means you can see Ethylamine can be prepared by the action of bromine and alcoholic KOH on propanamide. The reaction becomes like this: plus Br2 KOH, you get ethylamine. The byproduct is potassium carbonate, potassium bromide, and water. Hence, we get this one. The conclusion from this reaction: 3 carbons is equal to 2 carbons. 4 carbons is equal to 3 carbons. Like this, we have to go for the Hoffman's degradation method. Next one. Reduction of nitroalkanes yields which compound? So already I told how to prepare amines from the nitroalkanes or alkyl nitriles. Same question. Acid, alcohol, amine, diazo compound. First, let's see why not acid. Acid will not come because in nitroalkanes, if you remove the NO2 group, there is no H that is present, hydrogen proton. Alcohol, we may get alcohol, but OH nucleophile cannot be replacing the NO2. And amine, you know that it contains a nitrogen group, and we get the amine as a main product. Diazo compound, this will be having some doubt because it should contain N2. But why not this diazonium salt will be coming in? So you have to undergo the reaction called as Sand-Mears reaction. Okay. So the answer for this compound is alcohol. Why means, let's see. Reduction of nitroalkanes CS3 CH2. One second. It is not amine. It is alcohol. CS3 CH2NO2 plus 6 hydrogen in the presence of tin and HCl, which is reduction. We get CS3 CH2NH2 plus 2H2O. Therefore, we got the compound ethanamine or ethylamine. Okay, so this is the correct answer for this question. Next question. What is the name of the reaction when acetamide changes to methylamine? Again, the same concept, amide to amine. So, what is the name of this reaction now he is asking? Hoffman's bromamide reaction, only Hoffman reaction, Friedel-Crafts reaction, Hinsberg reaction. First, to understand what are the names of this reaction. Hoffman's bromamide means degradation, we get amines. Hoffman's reaction only, it is not there. Friedel-Crafts reaction is to prepare alkyl or acyl benzene. Hinsberg reaction is used to distinguish between the primary and secondary amines. Okay, so explanation you can see. When an amide is treated with the bromine in an aqueous or ethanolic solution of sodium hydroxide, degradation takes place and we get the compound which is primary amine. Okay, next one. When methyl iodide is heated with amine, what is the product obtained? Okay, so first he is asking methyl iodide CS3I plus NH3. You should heat. And what is the product he is asking? Methylamine, dimethylamine, trimethylamine, a mixture of all. So before 10 minutes when I was explaining the synopsis, I told you there is a limitations of Hoffman's because all the salts will be mixed and it is not easy to separate that mixture. Hence, only methylamine cannot be possible, only this one no. It contains all the mixture. Therefore, when methyl iodide is heated with ammonia, the product obtained is a mixture of all. You can see here, methyl iodide, ammonia, heat, we get primary amine, we get secondary amine, we get the tertiary amine. Therefore, it is related to Hoffman's process. Next question. The Hinsberg method is used for which of the following? The Hinsberg's method is used for which of the following? So before 2 minutes only I told Hinsberg reagent which form the orange color PPT. It is used to distinguish between first the options: preparation of primary amines, preparation of secondary amines, preparation of tertiary amines, separation of amine mixture. Okay. First 3 options it comes in the preparation, so no chance. Directly we go for the answer that is called as a D Hinsberg test. Okay, the explanation you can see. The Hinsberg reaction is a test for the detection of 1 degree, 2 degree and 3 degree amines. In this test, the amine is shaken well with the Hinsberg reagent in the presence of aqueous alkali. So let's see here. Hinsberg reagent you can take directly, but what are the other mixtures you are adding? Aqueous alkali KOH or NOH, A reagent containing an aqueous NaOH and benzene sulfonyl chloride is added to a substrate. So here, if you want, I will write two of the structures. Benzene sulfonyl chloride. So you can write the benzene structure here. Then you can write SO3 and Cl is the mixture. Okay. So like this, we are using the Hinsberg test. Next question. Which of the following compound gives a secondary amine on reduction? Till now we finished the questions only on primary amines. Now we have to go for the secondary amines on reduction. Nitromethane, nitrobenzene, methyl acetylcyanide, methyl cyanide. So let's see one by one. If I take isonitride, one second. Okay. Here if I take the formula CH3NO2, here C6H5NO2, and here CS3NC, and last one is CS3CN. These are the four compounds. When you reduce them, you should get secondary amine. So you can see here what happens. CS3 is there, NO2. Directly if you do reduction, we get primary amine. And when you do this one, you get the aniline. But when you take the CS3 and C, here C, there is one carbon. Due to that carbon and this carbon, it forms a secondary amine. Here also two carbons are there, but this carbon is bonded with another carbon. Therefore, the option for this one is methyl isocyanide. There is a change in the position of N and C. Answer C. Expression this one. I can write this reaction. C. CES3 N triple bond C plus 4 moles of hydrogen. If you do the reduction process, you get the compound CH3NHCH3. That is secondary amine is obtained. Okay. So now we have finished nearly 8 questions. Last question I will solve. Then in another class again I will continue with this amines only. Okay. Let's see the question. In the given reaction, what is the X? So again, he has given some reactions. You have to identify what will be the X, whether it is a product or a reactant. So again, I will write that reaction. R C double bond OH. Do the hydrolysis, you get X. And to that X, you add nascent hydrogen, you get the primary amine. Means I have prepared the primary amine 2 steps from the compound carboxylic acid. So what will be this compound X, and from what I have to make this reaction? Isonitrite, only nitrite, nitrite, oxime. Okay, oxime will be not coming here because we are not preparing the ether. So answer will go for is nitrite. How means when you take, so I will write reaction RC double bond OH carboxylic acid, and we do the hydrolysis, we get the compound C triple bond N. And whenever the C triple bond N comes, if you do the reduction, you get the primary amine, that is CS3, CH2, CH2, NH2, depending upon your R. Hence, the X compound which is given here, it is nothing but called as a nitrite compound, or you can also call it as a isocyanide. Okay. So these were the few questions which are related to amines. In next session also I will continue with another 5 to 6 questions. Okay. Thank you.